All right, what we were doing last day is determining types of reactions, and then what we're going to do is predict products. So our last thing to do is predict the product. So before we left, we determined the type of reaction. And to be honest with you, if you don't determine the type of reaction, it is very hard to predict the product. So always determine the type of reaction before you try to predict the product, because if you don't know what type of reaction it is, then you're not going to know how to figure out what product it is, okay? So make sure you always do that. So we know on that number, or the first one there that we haven't done, that it's a single displacement. Let's just kind of review that. How do we know that that's a single replacement or single displacement? How do we know that? How do we know that that's a single displacement? Tell me, Lucas. It's got not 3 elements. You're almost right. It's got one single element and a compound. It's got one single element and a compound. And what type of element is fluorine? Guys, be with me. If you're here today, be with me. Come on, some of you are off in La La Land. What type of element is fluorine? Metal or non-metal? It's a non-metal. So lithium is what type of element? Come on. Metal. Iodide is a non-metal. So what is fluorine going to replace? Who is fluorine going to replace? Iodide. So what's going to be kicked out as a free element? Who's going to be kicked out of this as a free single element? Iodine. Is it going to be iodide or iodine? Iodine, the element. So it's going to produce iodine. Let me get one of my pens. It's going to produce iodine. Plus lithium fluoride. Thank you.
Can you do this in reverse?
You could have written lithium fluoride plus iodine. Absolutely, doesn't matter. What you cannot have is iodine fluoride or fluorine iodide, and you could not have had lithium by itself, and you could not have fluorine lithide. It has to be lithium fluoride and it has to be iodine. I don't care about the order of them. That doesn't matter, okay? Yes or no on that? I know you're foggy. I know it's been a week, and I know it's hard to get back in the groove, and some of you have been sick as well. And we've got people out today because they're sick. Evidently, it's the flu, and it's wicked. So, all right. So now, once you have the words, then you write the formulas. So what is the formula for fluorine? Now, what do you have to remember? There's some 7 elements that you have to remember. Tell me. Diatomic. So what is fluorine? How do we write it? F2 plus lithium iodide. How do you write that? What's lithium's charge? +1. What's iodide's charge? -1. So what's the formula for lithium iodide? LiI. LiI yields iodine. How do I write it? I2 plus what's lithium's charge? +1. Fluoride is -1. So how do we write that? LiF. So fluorine is F2 plus LiI for lithium iodide yields iodine, which is I2, plus lithium fluoride, which is LiF. Now, we're still not done. What do we have to do now? Balance it. So how many fluorines do we have? 2. What do we have on the right? 1. So what do we put on the right? A 2. So put a 2 here. So that made 2 Li's. What do we put here? 2. That made 2 I's and 2 I's. Is that balanced? Balanced in? All right. Now, I think just in that one problem, and I'll be honest with you, that is a very simple problem. That problem was a very simple problem. But that's a lot of work. For those of you that don't know your ions, you don't know your polyatomic elements, I'm sorry, not your polyatomic, well, you don't know your polyatomic ions, you don't know your diatomic elements, and you don't understand what the heck we're doing anyway, that's a lot of work right there. Because it's a lot of thinking that you have to do. That's what you've got to do every time. And that's why chemistry builds upon itself. That's why we've been building all along here. That's why I pushed you guys at the very beginning, learn your elements. If you don't know your symbols and elements, then you can't do any of this. It's like learning how to read. Got to learn your phonics, got to learn your sounds, and that's what this is all about, basically. So, question on that one. Replace the non-metal. That's exactly right, Lucas. The non-metal replaces the non-metal. So you figure out what type of element, once you know it's a single displacement, then you figure out is this a non-metal or metal, and it's going to replace whichever type it is. So that's a good way to look at it. It's exactly what you need to do. Question on this? All right, what is the next type? You've already typed it before we left. What is the type? All right, on a double displacement. If you'll think of this as man, woman, or woman, man, I don't care how you think of it. But think of it like two marriages, two opposites, man, woman, positive, negative, that's what it really is. Think of it as that, and then what has to replace what? What switches? The positives can switch, it doesn't matter which one, just as long as they switch. 100% switch. And so, who is calcium going to be with on the other side? Oxide. So it's going to be calcium oxide plus, go ahead, potassium bromide. Potassium bromide. Calcium oxide plus potassium bromide. All right. Now, I'm going to be quiet for a minute and let you put in the charges. You put in the charges for these. Put the charges above the names. Put the charges above the names and then write the formula. Some of you are good at this and you know nomenclature. So what's calcium's charge? +2 bromide, -1 potassium. Say it again. +1 oxide, -2. So calcium again. +2 oxide, -2 potassium, +1 bromide, -1. So what's the formula for calcium bromide? CaBr2 plus A2O yields CaO plus KBr. Okay? Folks, every one of you should be able to do that. That's nomenclature. And that bothers me that some of you don't write it until I write it. You should be able to do this. All right, now to balance it, we have 1 calcium, 2 bromines. What do we need on this side? 2 in front. That made 2 Ks. That makes 2 Ks, 1 O, 1 O. Is that balanced now? That's balanced. Question on that one. Question on that. All right. Now, on these, we did not label the types for these. So I want you to go through right now, and I want you to label the type. Label the type of reaction. Label the type of reaction on these. You probably need to go back and review these. If you haven't looked at this lately, I would go back and review these, or at least have it flipped to that side while you're looking. All right, what's the first one? Chromic chloride plus cadmium. Single displacement, good. Single displacement. All right, so let's go ahead, and since we know that single displacement, let's go ahead and decide what are my products going to be. Cadmium is going to replace the chromium, so what's it going to be? Cadmium, chloride, and who gets kicked out? Chromium. Now, the problem is some of you may not realize chromic is chromium, and you have to know that. All right, let's finish this one. What's chromic's charge? +3, good. Chloride. Chloride, come on. -1. Cadmium, we don't have a charge there. Cadmium here is what? Come on. Cadmium plus 2. Chloride. -1. Chromium here, again, no charge. It's by itself. So when they're by themselves, they don't have a charge. So what's the formula for chromic chloride? CrCl3 plus Cd yields CdCl2 plus Cr. All right, now to balance this, I want you to balance it. Balance this one. All right, what do you put in front of CrCl3? 2, good. And what do you put in front of Cr here? 2. What do you put in front of this Cd? A 3, good, and a 3 here, good. So you remembered what to do when you had 3 on one side and 2 on the other, good. Very good. All right, the next one is what type? Combination or synthesis, it doesn't matter what you call it to me. Combination. And when you have a combination that's with an ionic compound, which you know it's going to be because it's a metal plus a non-metal, then you just, what is it? What's it going to be? What's lithium's charge going to be? When it becomes an ion, it's what? +1. What's sulfide? -2. So it's going to be, the name is going to be what? Lithium sulfide. The name is lithium sulfide, and then you just put it as the charges, Li2S. Now you have to balance it, so how do you balance that? 2 in front of Li. So don't make those harder. Don't make those harder than they are. Now, since you've already marked what type these are, let's go ahead and now and you tell me what you got these marked as. What kind is this? Combustion. Good job. Here, it's single displacement. This is a single displacement, and I purposefully tried to tell you that by writing water as HOH. Because by writing it as HOH, I'm trying to say to you this is barium replaces who? Hydrogen. And I think I wrote that. Yes, I did. Right here. If water on one side and hydroxide on the other, write water as HOH. So what I'm trying to say here is if I'm writing water as HOH, then what are you going to end up with on the other side? A hydroxide. Who's the hydroxide going to be? Treat this as hydrogen hydroxide. So it's going to be who? Say it. You're right. Barium hydroxide. Barium hydroxide plus who got kicked out? Hydrogen. Good. Now, let me go to lab. For those of you that had lab yesterday, for those of you that will have lab this week, for those of you that have had lab in the past, zinc plus hydrochloric acid. You did a reaction yesterday if you had lab, and this week you're going to do that reaction. Just going to put it down here for you. Zinc plus HCl yields when you put zinc in your hydrochloric acid, what happened yesterday, guys? Those of you that had lab. Come on, somebody had lab yesterday. This was a cool one. Say it.
Did it bubble?
It bubbled. What were the bubbles? Say it. Hydrogen gas. The bubbles were hydrogen gas. So you got out zinc chloride and hydrogen gas. And then what did you do to that hydrogen gas? You lit it and it went pop. It made that sound. And that's what you got to see. That's what you got to see yesterday. Now, this is not what we're doing up here, but it's a situation where hydrogen is released. Now, we don't, I'm trying to think, no, we don't do this one in lab. Did you do hot calcium, did you have any calcium and put it in water? I don't think you did in lab. I don't think you did. But if we had an experiment where you were putting calcium in water, the same thing happens. And barium too, same thing happens. Calcium hydroxide is formed and hydrogen gas is kicked out. Same thing's going to happen. So what up here happens, and I'm writing equations here. You don't have to write these down. I'm just showing you this is something you did in lab. It wasn't making a hydroxide, but it's when you get hydrogen out and you can burn the hydrogen, this same thing happens. Barium hydroxide and hydrogen gas is formed. Something I don't necessarily think sometimes you realize is, and I'm, I guess, not in the energetic mode to tell you today necessarily as well as I'd like, this is real. This is not made up. Chemistry is real. It really happens. I mean, this is something that's really happening. And if you, just to kind of give you an idea about the periodic table, if you look over here at the periodic table, do a Google sometimes, do a YouTube search for, you would do a YouTube video, on YouTube anyway too much. So go on YouTube, search sodium in water, potassium in water. Anybody know what's going to happen? It explodes. Sodium in water. Look down here. Is calcium a metal? Is calcium a metal? Is sodium a metal? Yeah. What's going to happen? If you just replace this, what's it going to be? Sodium plus water is going to give you what? Sodium hydroxide and hydrogen gas. So what they do is, or what not they do, what happens, what the chemistry is that happens is calcium is much less reactive than sodium. So I'm going to just show you something about the activity series on the periodic table. Or just the periodic table. Look at the periodic table over there, or anywhere, I don't care, wherever your periodic table is. Look at your periodic table. The first family, the alkali metals. So lithium, sodium, potassium, rubidium, cesium, francium. Now we need to kick francium out because it's radioactive and we're not dealing with francium. But when you take sodium, or lithium, sodium, potassium, and rubidium, they are more reactive than the alkaline earth metals. But the reactivity increases as you go down. So, do you remember last week or before spring break when I used McKinley and we jokingly talked about the more reactive element kicks out the less reactive? And I did it the way I did with just for humor, okay? Rubidium is more reactive than potassium. Potassium is more reactive than who? Who's above it? Sodium. Sodium is more reactive than lithium. So rubidium can kick potassium out. Can potassium kick rubidium out? No. It has to be more reactive in order to kick it out. So rubidium will replace potassium or kick it out. Potassium could replace sodium. Sodium could replace lithium. can every one of those replace hydrogen? Does that make sense? So why does this work? Why does this work? Calcium can replace hydrogen too because it's farther down. Even though it's less reactive because it's in the second column, it can still replace it. Now, can magnesium replace calcium? No, but calcium can replace magnesium. Who can replace calcium? Who else can replace calcium? Strontium can replace calcium. Can barium replace calcium? Now, so up here, is this one going to be a more violent reaction than this?
Yes.
Why? Because barium is farther down. Does that make sense? Barium is farther down. And so because hydrogen's way up at the top, these can react. So when I say go and look at this experiment, what happens, because lithium is not as reactive as sodium, but sodium and lithium will do this also. Lithium, when you put it in water, you start to see it fizzing. Not much though. Calcium, when you put it in water, it takes a while for you to see anything. You'll slowly, I tell you what calcium reminds me of. You know how when you put Sprite, you pour a glass of Sprite, no ice. You just pour a glass of Sprite and you start to see little bubbles around the edge. That's similar to what calcium will do. I'm not saying it's an experiment. You're not experimenting when you pour a glass of Sprite. I'm just saying that bubbles, it's kind of a slow, you put calcium in water and you'll see a little bit of a reaction slowly. If you put sodium in water though, depending upon, and I'm talking the size, see this little, just when it's like that, you can't see it very well. See how that's longer? Can't see it. That's longer. Now make it shorter. That little bitty amount of sodium in a beaker of water that's like that much water in one of those 250 milliliter beakers, as soon as you put it in, that sodium spins around the top of the water. And in just a little bit, it'll catch on fire. Because it has such a violent reaction and it causes so much heat, what's being produced is hydrogen gas, and is hydrogen gas extremely flammable? Yes. Do you all remember ever in history hearing about, is it the Hindenburg? Do you remember hearing about the Hindenburg? The Hindenburg was a blimp. It was basically a big balloon that they wanted to fly, and they filled it with hydrogen. It was a disaster. It was terrible. They filled it with hydrogen because hydrogen's lighter than air. So hydrogen would float. But what is hydrogen also? Extremely what? Flammable. And so it would just take a very little spark, static electricity spark even, and it blew the whole thing up. And it destroyed everything. And so they learned you can't, fill balloons with hydrogen. So that was a problem. And so that's why it catches on fire. Potassium takes even less amount of potassium to put that in water. Watch it sometime and you'll see this is real. This is real stuff, okay? All right. Let's finish this one. Since we've done it, let's finish it. So what's the formula for barium? Ba, water's HOH. Finish it up. So Ba what? Ba what? Say it again. Not just OH. OH2 plus H2, good. Got to remember. Got to remember diatomic. All right, to balance it then, what do we need to do to balance it? Two where? Two in front of H2O, or HOH. Now, on this paper, this is how I write it. Listen to me carefully, though. Is that how you're going to write it in sapling? No. You cannot write water as HOH in sapling. Okay? I said sapling. Achieve. Sorry, it used to be sapling. Thank you for your disturbed look. Achieve. I've been really good about that this semester. I don't think I messed that up yet. Achieve. Your achieve homework. Before I left, it was called sapling. Then they changed it to achieve, so I slipped. All right. So when you are doing it in achieve, let me write this down. Achieve homework must, maybe you'll look at your notes when you're doing your homework now, written as H2O. Okay? All right, let's go back up to the one above it. I left it out. Can you balance that one? I'm going to be quiet and let you balance that one. Balance the combustion one. If it's combustion, what's it going to produce, folks? Carbon dioxide and water. How do you know that? You're not looking, guys. Come on, look at your notes. It's right here. Complete combustion. And I told you if I give you one, it's going to be a complete combustion. I'll be the one to tell you if it's incomplete. So what are the products? Water and carbon dioxide. Keep going. All right, so tell me the products for this one. Strontium, nitrite, plus zinc, good. Keep going. Carbon dioxide and water. Keep going. Now, we got a problem here. Pick one. Iron 2 is the obvious to pick because it was cobalt 2, so I would have picked iron 2. If you pick iron 3, that's your choice. Just make sure whoever you pick, you have to write it accordingly. Plus cobalt. Good. Keep going. Sodium nitrite. Go ahead, plus aluminum phosphate. And carbon dioxide plus water. All right. Now, can you write formulas? Then write formulas. I've checked you on this part, so write formulas. The biggest issue here is that you all need to know nomenclature. So write your formulas and balance them. Go ahead and finish it. If you can finish it, then finish it. If you have finished them, then good job. All right, I've put in charges, so I'm going to start writing formulas, okay? So I'm going to do these for you, and you can check yourself. Hopefully you don't need me to do them for you, but I'm going to go on and do these. So strontium, Sr, plus zinc nitrite. Zinc is +2, nitrite's -1, so it's going to take 2 nitrites to produce then strontium nitrite. That's Sr +2, nitrite's -1, so NO2 2 plus zinc. Now the beautiful thing about that is because the ions had the same charges on each side, is that one already balanced? Yes, that one's already balanced. Question on that one? Does that make sense? All right. What, Lucas? Say it one more time, honey. No, zinc does not. Zinc is in the column. It's zinc, cadmium, and mercury. Everything in there is +2 always. Mercury can be mercury 1 or mercury 2, but it's still always +2. Yeah. Okay? All right, so C6H12 plus O2 yields CO2 plus H2O. We got that one balanced already? Yes, no? Nope. All right, then balance it. Balance that one. All right, what do we have? 6 carbon, so what do we put over here? 6. How many hydrogens do we have here? 12. So what do we put in front of the water? 6. That made 12. Yes, no? All right, and that gives us 12 plus 6 is how many total oxygen? 18, so what goes here? 9. Good. Okay. All right, so formula for cobalt 2 sulfate. CO, SO4, good, plus Fe yields FeSO4, very good, plus CO. And again, the beautiful thing is because everything had the same charge, it's balanced. That makes sense? All right. Sodium phosphate's formula. Somebody's ready to get out of here, I agree. All right, keep going. Aluminum, parentheses, NO2, 3, yields NaNO2 plus, good, somebody knows their ions. Guys, that's what you all need to be able to do. You need to know those. Now balance it. What do you do to balance it? 3 where? Good. NaNO2, put a 3 here. That made 3 NAs. There's a PO4, PO4, an Al, 3 NO2s, 3 NO2s. Yes or no? All right. Can you write the last one? You already got it written? We don't normally go this slow, do we? Have we already got it balanced? I think about half of you do. Let's let the rest of them get caught up. All right, what goes in front of CO2? 12. Okay. What goes in front of hydrogen? And what goes in front of O2? Good job. All right, questions on that? All right. Do you know what you need to work on? So, your homework is due on the 2nd. Yes, your homework is due on the 2nd. I want to mention 2 more things. that you have 2 class periods. Guys, listen to me for just a minute. We're going to get out early. Can you just give me quiet for a minute? You're going to have 2 class periods before your next test. So you've got Thursday and Tuesday. Get off your phone. Listen to me. You're going to be on your phone. You can wait. Oh my gosh. You can wait for 2 seconds here, 2 minutes. Got my blood pressure up. Stoichiometry is what our next topic is. Stoichiometry is putting together what we did with mole-gram conversions and equations. So if you don't know what you're doing here, stoichiometry is going to be even harder. So don't be lackadaisical and wait to do your homework. Get the homework done before Thursday, so that Thursday, when we're doing stoichiometry, you can focus on that, okay? There is extra practice on Blackboard. Do it. The 28th is the last day to drop this class with a W, okay? Your test is not until later. So you're going to have to make a decision now, whether you're going to stay in the class or not, okay? So we will stop now. I will see you on Thursday and hopefully have more energy Thursday.